So for problem 21.3, an electron gun releases only one electron per shoot. It is shot towards a proton, which is at 1 meter away from the electron. Find the force of attraction between electron and proton. And we're assuming it's 1 meter apart in this scenario. So for problem 21.3, electron and a proton are separated by a meter, and our entire equation for this, the force between them, is going to be 4 pi epsilon naught times absolute value of charge 1 and charge 2 divided by the distance. R here is the distance squared. So we know what these both are. What we need to do is specify that this is 8.854 times 10 to the negative 12 farads per second. This is the permittivity of free space. In a vacuum, though, I should specify. So whenever you're doing something, consider what atmosphere you're in. It could be in, I don't know, water, or a vacuum, or really anything. Epsilon naught is in a vacuum. So most of the problems in this book, I think, are in a vacuum. So you could honestly just memorize this right here. 1 over 4 pi epsilon naught, as it says in the textbook, is equal to 8.988 times 10 to the 9 Newton meters squared per coulomb. So we'll just substitute this whole thing into that right there, that equation. And then charge 1, we need to know, and we could use from earlier problem 21.2, if you can see it right there. 1 coulomb is actually equal to 6.24 times 10 to the 18 electrons. So then 1 electron, we're just going to divide it by this. 1 electron, and an electron is the same charge as a proton, but just positive. So we're just going to multiply this right here for both these. 6.24 times 10 to the 18 electrons, 1 coulomb. I'm going to go ahead and get my calculator out. 1 divided by 6.24. Of course, put our parentheses in here so we don't get any errors. It's power of 18. 1.603 times 10 to the negative 19 coulombs per electron, or per proton. So now that we have that, our force right here is just going to be 8.988 times 10 to the 9. I'm going to multiply that by the absolute value of 1.603 times 10 to the 19 coulombs. I'm just going to put it in here, square it. I mean, it's one of these charges is positive and the other charge is negative. But since we're doing the absolute value and we're squaring it anyway because it's the same charge, I mean, we could just add the absolute value there just in case. Divide it by 1 meter squared. Of course, we want to put the parentheses around that, but 1 times 1 is still 1, so it doesn't entirely matter. So now what we're going to do is 8.988 times 10 to the power of 9 we're going to multiply that. Oh, and I should put the units for here. I'll just kind of append them here at the end. Newton meters squared per coulomb squared. That's always important. And so you can kind of see our units cancel out to newtons, which is what we want for force. So we multiply that by, put that in parentheses. Yep, everything looks in order. So then we get our force is 2.3096 times 10 to the negative 28 newtons.